Hello everyone, I'm Paul and today we're solving problem 3542, minimum operations to convert all elements to zero. This is medium and the key for this is observation, so let's start. We are given an integer array nums and we need to return the minimum number of operations to make all elements in the array equal to zero. In each operation, we can select a subarray and set all occurrences of the minimum non-negative integer to zero. In case you don't know what a subarray is, it's a contiguous sequence of elements. So for example, this is a subarray, this is a subarray, but we can't form a subarray with these two elements because they are not contiguous. Let's say that we're given this array. The result is initially 0, and we can use one operation to transform the minimum non-negative integer in this subarray to 0. And we can use another operation to transform the minimum non-negative integer here, meaning number 2, to 0. So this is now 0 and this is 0. And the result in this case is 2. I like to visualize this as a bar chart. So let's say that we are given this array, result is initially 0, we start from index 0 and we are reading this from left to right. So first we are here and the visual representation of this up to this moment is this. We need one operation for sure to transform this to 0. So we add 1 to the result and continue. Next, we are here, so let's say that the array ends here, we don't have this, and given that this is greater than this, we need to use one more operation for sure. We are using one operation for this and another one for this, so we add 1 to the result. Now we are here, so let's say the array ends here, we don't have this, and there's no question that when we have a number that's greater than the previous number, here we have a difference, so we need to use another operation. This is now free. Now what if we have a number that's smaller than the previous number? Well, in this case, it might be a case that we have already seen this number, and actually here we have another free. So how can we handle this? The answer is we can have a monotonic stack. And more specifically, we are using a monotonically increasing stack. In case you don't know what this is, it's just a stack where we store elements that are monotonically increasing. So as we iterate this from left to right, whenever we find an element that's greater than the previous one, we just add the element. Now, what if we find an element that's smaller than the last element in the stack? So here we have a 3 and 3 is smaller than the previous number, which is 4. And we could use one operation for this, but maybe we have already seen number 3. Actually, we have a 3 here. So we can take this subarray and transform this and this to 0 in only one operation, because we are trying to get the minimum number of operations. So whenever we find a number that's smaller than the previous number, we can pop the last element in the monotonically increasing stack, and we are repeating the same until the last element in the stack is smaller or equal to the current number. So this is monotonically increasing. Elements are greater or equal to previous elements. And now the last element in the stack is equal to the current element, meaning this is equal to this. So we are using one subarray to transform these two elements to 0, so we don't add anything to the result. Here we have a number that's greater than the last element in the stack. So this is as if we don't have this and we have this, okay? Now, given that this is greater than this, we add 1 to the result. And maybe you are wondering why. If here we have a 4, why can't we just select this array and transform these two elements to 0? And the answer is we need to take the minimum number in the subarray, so we can't take these two 4. So whenever we find a number that's greater than the last element in the stack, meaning this is increasing, we add 1 to the result. and the largest element so far is 4, so we add 4 here to the stack. Now we have a 2, and 2 is smaller than the last element in the stack, so we could use an operation for this, but maybe we have a 2 before. So we need to pop elements in the stack while the last element is greater than the current element. So we pop this, which is as if we remove this. We pop this, which is as if we remove this. Remember, we didn't have this, and given that we pop 3, now we don't have this. Okay, so now this is monotonically increasing again. The last element here is 1, the current element is 2. So this is the largest element that's smaller or equal to the current number. And we have already gone through every element in between, and none of this was equal to the current number. And this element, which is the last element in the stack, is smaller than the current number. So here we are ready to say that we can use another operation for this. So this is now 5, and we add 2 to the stack. Now we reach the end and return the result 5. And this is as if we select this array, transform this to 0. Here we have one operation. Then we select this, transform these 2 elements, the minimum element in the subarray, to 0. Now the number of operations is 2. Then we select this number is 3. Then we select this. The number is 4. Finally, we select this, and the final number is 5. Okay? And by using this monotonically increasing stack, we are solving this in big O of n time and space complexity. So with this in mind, let's go with the code. First, n is the length of nums. The result is 0. We have an empty stack. And now we can say for every number nums, while we have something in the stack and the last element is greater than the current number, given that we have a monotonically increasing stack, we pop the last element. Now, if the current number is 0, we can just continue because we are not using operations here. And if we don't have anything in the stack, or the last element is smaller than the current number, here we are ready to add the current number to the stack and add 1 to the result. Finally, return result. This is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, drop a like, subscribe, and see you in the next one. Bye bye.